Hello and welcome everyone to the latest iBwave webinar. Today's topic is network convergence and the need for future proofing. Our guest speaker today is Dean Bubley from Disruptive Analysis, an independent technology industry analyst and consulting firm. Dean is an analyst with over 20 years experience. He specializes in wireless, mobile, and telecom fields. He is one of the leading analysts covering mobile networks, service provider business models, the future of voice, and WebRTC. Now, before we get started, I just want to go over a few housekeeping items. If we can go to the next slide, please.
You should have it.
I think there's a bit of a delay. Don't see it.
Okay, I've got it on my screen.
So just to go over a few housekeeping items, you should be receiving a recording. There it is, a recording of the webinar within the next few days. So look out for that. And during the webinar, if you have any questions, please ask them using the GoToWebinar questions box, and we'll get to the questions towards the end of the webinar. And now I will hand it over to Dean to get us started.
Thank you very much, Amna. Hi, so I'm Dean Bubley. I'm a technology industry analyst and futurist, and I cover a whole range of areas primarily around telecommunications, particularly wireless networks, but also regulatory policy, areas to do with technology innovation, both on the wireless and wireline side, and increasingly a whole set of other adjacent areas to do with Internet of Things, things like artificial intelligence, blockchain, and how those fit into the general sort of wireless and networking sphere. Those of you who know me from my Twitter alter ego of Disruptive Dean will know that I tend to be sometimes slightly controversial, so hopefully there'll be one or two surprising things that come out of this, and we have opportunity for Q&A at the end for anyone who wants to question or challenge some of the things that I'll be asserting. So to dive straight in, we talk about this word convergence a lot. I mean, I've been following technology convergence in one form or another for a very long time. I've sort of been presenting on it for more than 20 years. And if you like, one of the things that I note is that I suppose it's almost like a law of mechanics or thermodynamics, that for every instance of convergence, there's usually an equal and opposite trend towards divergence, because the underlying technology converges, which allows new use cases and new participants, new ideas to benefit from economic change and standardization and simplicity. And so when I look at what's going on for in-building communication systems, particularly relating to wireless, there's almost like a Cambrian explosion at the moment of developments. Obviously, everyone's talking about 5G, but there's also sort of the other related and sometimes complementary and sometimes antagonistic trends around new spectrum bands, changes as well going on in Wi-Fi and other network technologies. There's a lot of new players coming into the market, whether those are in-building specialists and neutral hosts. It could be property companies who are looking to monetize the investments they put into building wireless and wireline coverage. There's obviously a lot of interest in new use cases for networks inside buildings, and I'll come through and talk about those over the next half an hour or 40 minutes. Certainly, there's a lot to discuss around specific industry verticals, and that tends to get quite a lot of play when people talk about 5G as well. There are regional differences, both in terms of policy and spectrum availability, but also in terms of things that we don't always think about from a technology point of view, like construction materials. And when you're talking about wireless propagation, the difference between some parts of the world where buildings often have wooden frames and others where you may have steel, concrete, and in particular window materials, which maybe have a metal foil to combat heat loss or heat gain from external ambient conditions. That's something which also plays in here. So I'll touch on all of these points and look at over the next sort of 5 to 10 years to sort of how we can expect that to change the environment. And if you like, just to sort of almost like give the answer up front, I mean, the main point that I want people to take away is that the future is highly unpredictable when it comes to networking. Certain things we can be confident of, but there's quite a few, if you like, unknowns, and there's a lot of orthogonal trends in technology, business, users, and society that we need to have the inbuilt future-proofing and flexibility as much as possible. And that's certainly a theme I'll touch on throughout the presentation. One of the problems here is you cannot put all of the ongoing changes and requirements for wireless networks on a nice simple map or 2x2 chart. I started trying to map out what we need from future wireless networks, and I basically ran out of dimensions that I could comfortably put on a 2-dimensional slide. And given PowerPoint at the moment doesn't allow me to do 5 or 10-dimensional hypercubes, I'll have to talk through this as best I can, just to sort of illustrate the scale and scope of the problems. And I think that the first thing that's important to talk about is the usual description of wireless in terms of speeds and distances, bandwidth and range. And we're pretty familiar with that, but it's worth saying that these numbers span over many orders of magnitude, depending on the use cases, technology type of requirement, from high-speed video and in future augmented reality, and obviously things like server-to-server communications, which can have gigabits a second or even terabits a second of requirements, right down to some of the IoT use cases for sensors or other sort of low data rate machine-to-machine uses, which could be measured in bits per day. So perhaps 10 or even 12 orders of magnitude difference. And similarly, the range of these technologies, some will be spanning citywide areas from outside to in, some will be very short range in building only technologies, and some like cellular and to some extent Wi-Fi will sort of sit rather uncomfortably in this sort of 10, 100, 1,000 meter range, which blends outside to indoor only, outdoor only, and so on, where depending on the frequency band and the power and the nature of the antennas, you have a mix of both public services on private property and vice versa. Other dimensions to consider, the importance of connectivity is one that cannot be underestimated, and the types of network that are going to be used for things which are, I don't know, nice to have versus, from a business point of view, must have, and then at the other end of the spectrum, safety critical and life critical for things like public safety connectivity, or for machinery on industrial sites, which has perhaps dangerous outcomes if something goes wrong, for example, on an oil refinery. Those all have very, very different requirements that flow back through to the need for connectivity on that premise. Linked to that is the coverage requirement, and we're used to talking about 90 or 99% of coverage, whether that's outdoor or indoor. We also have to start thinking about volumetric and 3D coverage, again, where we have things like Internet of Things, where you may well have connected devices which are in ceiling voids or under the floor, and in future we may have robots and small drones as well, which sort of essentially have to make us think more carefully about the third dimension of space as well. Other dimensions that will come into play is how the devices get powered, and how, for example, that impacts on the way we do connectivity to optimize for power consumption in some cases, who owns networks and who takes liability if something goes wrong, security, the requirements on mobility, how fast you need to be able to hand off from one part of a network to another, and so forth. There's a lot that's going to be changing, and there's going to be multiple slices across this pan-dimensional landscape that we need to consider in future. And This is made further complicated by each industry and each sector, both in terms of industries, but also in terms of building type, will have its own separate set of requirements, either because of a different mix of visitors and employees, tenants, owners, or because of particular regulatory or technical requirements that apply in particular areas. Most, for example, a hospital or an airport will have very specific sets of regulations that are industry specific, relating to RF emissions. In an industrial facility, you may have welding machinery which could put out broadband RF interference, and you have a set of requirements around the user behavior which may be different from a convention center to a tunnel between two terminals in an airport, to obviously a sports stadium or other event space where you have perhaps certainly less criticality from a safety point of view for the video screens, but you have very, very high densities of usage. And one of the things we will need to be thinking about is, for any given location, how those requirements may change as other parts of the technology stack evolve. Will we have people walking through airports with virtual reality headsets? I don't think so, but we may well have people wanting 3D video playback in a sports arena. And this also applies to more sort of traditional carpeted offices and business environments as well. Whether that's changes in ownership model, where you have building as a service, and organizations like WeWork or Regus that are renting out buildings to temporary users, where there's different parts of the building that have people on different networks at different parts of the day. A whole set of interesting things around hospitality, hotels, where it could be theme parks, or restaurants where you have an expectation of certain types of connectivity, whether that's cellular or Wi-Fi, where you have people coming from different nationalities and different networks who may have different experiences around roaming. They may have devices that support certain subsets of spectrum bands and certain classes of wireless network. So there's a lot of actually like softer issues as well as the hard technology, which I'll come on to in future as well. And as we go forward, we may also have some interesting requirements around not just the network, but also the compute, perhaps integrated with the connectivity. There's a lot of discussion around edge computing at the moment, and there's a lot of debate as to where we will see the future of distributed and decentralized computing, whether that's built into the fabric of the network, whether it's mesh-based in some way, and perhaps even whether it's using distributed technologies like blockchains. And last off, we do have, as well as the sort of strictly indoor usage, which is worth remembering as well, that there's interest in general in areas that have poor coverage of wireless technologies today, for example, in rural communities. So moving on, one of the big challenges is going to be the diversity of spectrum that gets used for wireless networks, especially 5G, over the next 5 to 10 years. And at the moment, almost all 2G, 3G, 4G networks operate between 700 megahertz and 2.6 gigahertz. And most of the current installed base of building systems is designed to cope with that range. And there's an awful lot of existing infrastructure which perhaps will not be able to easily extend to the much higher frequencies that are expected to be used more broadly over the coming years. The backstory here is that there have been massive increases in the power and capability of the processors used in both the radio side and the device side of networks in recent years, which has allowed a lot more clever use of high frequencies, even where they don't traditionally propagate well through building materials. And so we're able to use beamforming, multiple antennas, and that's this term MIMO, multiple in, multiple out. And there's going to be a set of techniques techniques which essentially allow these much higher frequency levels, which enable higher overall throughputs, to be used with the computing requirements in the network to make them effective, whereas that's not been the case in the past. So you've got a lot of interest at the moment around mid-band technology. That's particularly between 3 and 6 gigahertz, and we should be expecting to see a lot of 5G networks deploy in the 3.5 band, 4 gigahertz band, depending where you are in the world. We may also see Wi-Fi, I'll talk about Wi-Fi in a second, adopting new spectrum between 5 and 6 gigahertz. There's a huge amount of interest in the millimeter wave bands, the high bands, typically in the sort of 24 to 28 range, and various in the 30 gigahertz, and then also unlicensed spectrum in 60 gigahertz, and then perhaps higher still in coming years. And historically, those have been used for point-to-point links out externally, but we're now seeing a lot of the early 5G trials and commercial deployments probably going to be using 26 or 28 gigahertz. Certainly in South Korea and North America, 28 seems to be a popular number, but there's also a number of other players outside of the cellular and 5G world who are using 60 gigahertz for fixed wireless connectivity, and Facebook's Telegraph technology, for example, or Starry, which is using a variety of Wi-Fi for external building access as well. And the question then is going to be whether they can go from outside to inside, whether they convert to Wi-Fi indoors with some sort of outdoor to indoor transition and gateway. And then lastly, there's going to be some more interest around the low band technologies. These are ones, though, sub-gigahertz, which probably have much greater chance of doing outdoor to indoor penetration effectively. And they're going to be used for typically low bandwidth, low power, wide area solutions for smart cities or for various industrial IoT use cases. But you also have some carriers like T-Mobile in the US, which are looking quite aggressively at 600 megahertz for their normal 5G coverage layer as well. And then on top of this, there's a lot of other technology enhancements that are going to get exploited as either part of 5G or part of the other alternative technologies. I've mentioned beamforming in particular, but again, it's a little bit unclear how that will act indoors, particularly in buildings which have traditional distributed antenna DAS systems, which may be able to sort of have a few antennas. I've heard people talk about 4 transmit and receive, for example. But when you compare that with the outdoor flavors of 5G, which might have 32 by 32 antenna arrays, it's not obvious exactly how that's going to translate to indoors. And one of the implications of this is that we may end up with what are termed neutral host networks indoors, which aggregate multiple carriers onto the same infrastructure, which sounds great in principle, but is far from easy from doing in reality. Most existing in-building systems typically only have one or two of the carriers actually signed up to it, and there's a lot of question marks about who actually pays for both the connectivity and the infrastructure and installation and operations and maintenance. Whilst there's a lot of discussion around 5G, it's important we also remember that a lot of the in-building focus will remain on Wi-Fi. There have been various, frankly, in my view, scare stories that 5G or even 4G things like flat rate data plans might impact Wi-Fi's relevance, and my advice is not to give any serious credence to that. My belief is that outdoors cellular technologies are not going to be challenged significantly for most uses, particularly for high mobility uses of people with phones or vehicles. But indoors, there's a lot more cleverness and speed in the Wi-Fi community than I think some in the cellular industry give credit for. I was at a Wi-Fi event a couple of weeks ago, and it was very notable, the focus on in-building meshes, the use of AI technology to pinpoint not just coverage at one point in the building, but try to almost map out the interior of the building intelligently in the Wi-Fi infrastructure, and also where the users tend to be, and to use that to cover not even, if you like, every square inch, but more every cubic inch of the location. There's a lot of other enhancements that are coming, whether that's the 60 gigahertz multi-gigabit capability. There's what's called 802.11ax, which uses OFDMA technology to give more effective congestion management and quality of service, and it's particularly aimed at dense usage scenarios. There are certainly going to be a lot of interesting participants from both the carrier community, the cable operators, as well as the sort of building service providers offering managed Wi-Fi. And there's a number of organizations that are even looking at sort of, again, blockchain-based Wi-Fi access, and for communities or for new types of business model. And way out on the horizon, there's even some people who are trying to do things other than connectivity with Wi-Fi. I met with one company recently that's using Wi-Fi to do actual sensing of moving physical objects within a building, and actually using the sort of disturbances in the RF field to do things like detecting motion, potentially through walls. And they were actually comparing their technology not with cellular, but with light bulbs and visible light. Another trend that's coming, which is going to sort of make this whole environment more complicated, is cloud RAN and virtual RAN for cellular. And this sort of blends the private and public spaces and the wide and local areas in a further set of ways. The general principle behind Cloud RAN is to separate the antenna part of base stations from the computing part, and particularly as that compute function becomes more complicated and more sophisticated in terms of sort of planning how the radio network manages individual users or capacity between different cell sites. It makes sense to centralize it either in what are called base station hotels or in regional data centers. And you then have, and there's different architectures for doing this, you then have what are called remote radio heads, which are essentially the antenna and associated equipment, which is a sort of a lighter, both physically and electronically, a component that is installed. It could be outdoor on roadside furniture, but it could also be in building as well. And linked with optical connectivity, what is called, most people are familiar with the term backhaul, which is the connection between a cellular base station and the core network. The term front haul, or sometimes combining them to call them X-haul, is becoming popularized here as well. And so what you may well find is that the front haul from the edge compute or the edge base station baseband units is both optical, if you like, optical connections outdoors, but then within the building is also optical. And that then starts to become hybridized potentially with the optical LAN infrastructure, local area networks, that some enterprises are putting in as well. So again, this is a slightly different form of convergence. We're still at very early stages of this as to exactly how this is going to pan out. The number of carriers who are doing even outdoor Cloud RAN is still comparatively low, but there is an expectation that along with 5G, we'll see these models evolve substantially. And so when you start having a Cloud RAN meets in building, I think we're going to see some interesting innovation in coming years. So moving a little bit back to Spectrum, but talking about new stakeholders. And at the moment, in most parts of the world, Spectrum for mobile networks or cellular networks is delivered via national licenses or national carriers. In some cases, it's sort of regionalized. You have sort of circles in India, and the US still has a number of smaller regional carriers in particularly rural areas. But for the most part, there's three or four cellular operators that are the bulk of the connectivity provided in most of the countries of the world. And obviously you have, for example, the Sprint and T-Mobile merger, which is potentially going through in the US, which would reduce the number of national carriers down to 3, as you see in China and a number of other countries. And today, they are the main providers of mobile network services, and that's served us very well. There's been obviously huge growth to whatever the current number is, 7 billion subscribers globally over the last couple of decades. And they've tended to be either ordinary business to consumer, prepay and postpay subscriptions, some used for IoT, and there's a certain level of wholesale activity through virtual operators. In some markets, there's also been a couple of providers of mobile networks that are not traditional mobile operators. So you might find a couple of government-run cellular networks for things like public safety. And there's a few businesses like utility companies and rail companies that have run their own networks. My view, and also that of an increasing number of people across the industry, is that's insufficient to meet some of the diverse sets of needs that I highlighted earlier. And as well as the network infrastructure, there's a lot of interest in new forms of spectrum authorization and allocation. And depending where you are, you'll come across proposals for shared spectrum, dynamic spectrum, sub-licensing of existing national licenses on a regional basis, what's called secondary reuse, which is where if a national operator hasn't built out a network in a certain area, it might become possible for another party to use that network if they don't cause interference, or use that spectrum if they don't cause interference. There's a lot of regulatory action and obviously lobbying that's going on here. Probably the most well-known at the moment is the CBRS technology, which is being pitched in North America and US, where there's a slice of spectrum around 3.5 gigahertz, which is just the rules are being finalized at the moment. But the idea is that some of that spectrum will be available on a sort of license per area basis, subject to preemption rights by a couple of incumbents like the US Navy. And then there's also going to be what's called a general access tier, which is a sort of I suppose a glorified Wi-Fi type approach, where as long as no one else is using a particular piece of spectrum, then other people can, as long as they check with the database that is okay. And a lot of the rest of the world's regulators are looking at CBRS to see how that evolves. Some others are looking at offering either dedicated or geographically defined spectrum for, say, industrial companies or cities. So I think we'll see quite a lot of movement on this over the next 5 years. And that's got some interesting implications for building owners and other asset owners and service providers, in terms of how their either existing or future infrastructures support both the frequencies that these are, which are typically in the 3.3 to 4 gigahertz range, but also the diversity of network owners and operators who may want to have access to in-building systems. And I think that this slide really, for me, highlights the diversity we should be expecting. There's such a lot of different stakeholders who may have skin in the game when it comes to networks over the next 5 to 10 years. We have a number of shared government-run networks. So, for example, there's a 4G network in Mexico that's designed as a wholesale network and run by the government. I was talking to the 5G specialist for a major European city's municipal authority last week, who was looking into whether or not they could get their own dedicated bands. Utilities and infrastructure providers, industrial companies where you may well find it could be an oil refinery, or it could be a wind turbine farm high on a hilltop, or even offshore, doing wind generation where the owner wants to use drones to inspect the turbine blades. They're obviously not going to get national network coverage in the middle of nowhere, so they may well look to build out their own connectivity. There's this sort of idea of neutral hosts, which we've seen some movement in already where people are using small cells, perhaps either shared small cells between multiple carriers, or even in some cases open cell in the UK, for example, where they put in infrastructure in buildings and they put a small cell for each of the different network operators, maybe 1 or 2 clusters of small cells per floor of the building. And then I've mentioned also rural providers, perhaps niche MNOs. We may well find solution integrators coming from the IoT background. You might find a General Electric or a Bosch or a Philips in the future as well, embedding wide area connectivity into their products, as well as sort of meshes and decentralized use cases. That's not to say that it's going to be easy for any of these new entrants to create networks, as well as the radio challenges around spectrum, around in-building, around small cells, Wi-Fi. They're going to have a lot of other, if you like, moving parts to consider, from the software side of things to SIM cards to the OSS BSS and what they do about numbering and so on. But I think that there's such a lot of interest here, and a lot of companies that are looking to provide managed services for the trickier components of this, that we're going to start to see a much broader ecology of market participants in wireless networks in the next few years. And we're starting to see this already, partly through licensed spectrum and partly through unlicensed spectrum. And it's worth saying as well that some of the cellular networks are going to be running in unlicensed bands as well as licensed. We have LTE-U and LAA and multifier, which allow LTE and future 5G connectivity to run in the bands predominantly today used by Wi-Fi and Bluetooth and other technologies, potentially with listen before talk for sort of friendly coexistence, but the rules on that are likely to be different depending where you are in the world. I referenced edge computing, but this is another dimension of convergence that it's worth drilling into. And just to say that as well as the cellular or Wi-Fi or other wireless networks, these are going to become increasingly entwined with the computing resources used for different applications. And this is particularly relevant for Internet of Things use cases where low latencies are required. The latency isn't just in the network. A lot of people talk about 5G as offering 1 to 10 millisecond latency. But there's also going to be a case of where you put the compute resource. There's a lot of debate here. I have to say I'm a little bit skeptical about the idea that we're going to see a lot of edge compute actually in the cellular or in the Wi-Fi network. I think it's going to be in building, and in some cases it's going to be physically located in maybe secondary and tertiary data centers in small towns or on farms or in a gateway node or so on. But we also see a certain number of functions that are actually integrated directly into the network. It could be on the street cabinets through a cable company, it could be on a cell tower, or it could be at network aggregation points. I've done some analysis to suggest that that's probably only going to be 1 to 2% on the optimistic assumptions of the total compute. And the vast bulk of compute for IoT will remain either in hyperscale cloud data centers or actually on the device themselves. You look at something like a vehicle, and the vehicle, essentially an autonomous vehicle of the future will essentially be a supercomputer on wheels, which probably has more compute capabilities than large amounts of the network infrastructure. But this is going to be quite interesting where you converge this within building. And the question is going to be whether some building or property owners, in essence, become micro data center providers, either on their own or in conjunction with service providers, providing compute capabilities for low latency requiring applications that are on premise. I'd say it's probably still too early to really picture how that's going to evolve. And one of the things I would say, whenever I speak to people, not just on the application side, but frankly, even on the cellular side, people often forget about the difficulties of providing in-building networks and the timescales and costs involved in particularly dealing with the existing install base of physical locations, and the assumption that you could just sort of put a server at the side of the road or something like that starts to become very much more complicated, where you have property owners, tenants, building regulations as well involved. So I think it's going to take us a few years to work through exactly what the convergence pattern for edge compute and indoor wireless looks like. We should certainly see some innovation around that. One other thing that I'm noting is an increased emphasis on the value of in-building connectivity for building owners and property developers. And this is sort of starting to become something which actually directly translates into rents and leasing rates, occupancy levels. And so I think there's this thing, the Wired score, which is a rating system for this, which is both the wired and wireless capabilities of a given building. And I think that as we move towards an expectation that everyone can use both their phone everywhere, we have IoT devices of varying importance everywhere, but also as buildings get more sophisticated with the building management systems themselves, and also the insulation required for environmental protection, which means that sometimes the outdoor to indoor wireless signals are essentially blocked and the building becomes almost a Faraday cage. I think that there's going to be a lot more emphasis that's placed on measuring, monitoring and updating the capabilities of different structures and buildings, and not just for one network, but also on multiple different networks. I think there's often a big emphasis at the moment for one or two carriers to have coverage inside a building, but I think that if you think through the requirements of visitors, the different ways that people work in, say, a serviced office where you simply can't dictate that everyone uses the same mobile network, because you have guests, you have customers, you have consultants and contractors coming on site with their own devices. And so there will be a requirement and an expectation that every network works, well, if not everywhere, then as close to it as possible. So to sort of start wrapping up, my view is that we're going to see a sort of a phased approach to this concept of network convergence. And we're going to go from a world where, well, today, the in-building environment for cellular is often quite separate to the Wi-Fi implementation, critical communications coverage, and the business typically wired local area network for computers. We're starting to sort of see different parts of this already converge. The middle set of, if you like, Olympic-style hoops in the middle. They're starting to converge already. Obviously, the sort of small cells, distributed antennas, and 4G macro network tend to be converging fairly rapidly. Also, in some cases, the Wi-Fi infrastructure and cellular in building is becoming more tightly coupled, and certainly either in terms of functional responsibility, but also on the technology and planning sides as well. We're seeing convergence between the Wi-Fi and the wired LAN, insofar as a decreasing proportion of devices that people use in buildings actually use a physical wired connection to an RJ45 socket. I think I've used the plug on my laptop once in the last year in a hotel somewhere, and a lot of modern laptops simply do not have Ethernet ports at all, and there's an expectation that people use Wi-Fi throughout the building, diminishing number of desktop PCs, except in places like maybe contact centers and a few other locations. But we're starting to see that convergence channel occur as well. And there's also this sort of link with the Internet of Things, and perhaps to a lesser degree the critical communications side of things. In fact, the critical communications and public safety, I noticed today, in fact, there was a story that the UK government is having second thoughts about using 4G, at least in the short term, to replace its old sort of wireless voice network for police and fire officers. So that may take a little while yet to converge, but it may also give more regulatory requirements in future. You can certainly imagine that in 5 or 10 years' time, there'll be an expectation from the fire service in many places that they'll be able to use their robots or drones in building, communicating with the management and control function under control outside. So I think that we'll see progressive integration of these, particularly as you move towards 5G, as you see some of the local area networks transition from twisted pair to optical, and optical fiber getting pushed deeper into buildings. And I think that Wi-Fi will continue to have a central role for both employees and visitors, and also actually probably the vast bulk of Internet of Things devices as well. I haven't mentioned the LPWA, low power wide area connectivity. That is becoming more important, but tends to use lower frequency bands. But we may find some use cases where there will need to be either repeaters or integration of a LoRa or Sigfox network with building infrastructure as well. So to finalize and to summarize my last slide, it's impossible to know everything that is going to occur over the next 5 to 10 years with in-building or on-premise wireless. There are simply too many moving parts to gauge absolutely what the end state will look like. And it's likely to vary by physical location, by country, and from the perspective of different users and tenants. We know where we are today, and there's certain things we also can determine as being inevitable. So there will be more of a user demand for cellular, mobile broadband or smartphones. There will be more Internet of Things devices of different categories. But then when we get beyond that, we start thinking about, well, what is 5G going to look like indoors? How much attention is going to be put on large office buildings? Or is that an afterthought after people have done the sort of outdoor environments, the fixed wireless to homes and residences and a few sports stadiums? Are we going to end up with a 5-year, 10-year cycle of training engineers to install and upgrade existing DAS systems and small cells to 5G? My sense is that there's a lot of pathways to there. It's going to depend on regulation. It's going to depend on who pays and who has the money to pay and willingness to pay. And it's also going to depend on collaboration between different carriers in in any one market. Often, a number of the national carriers are loath to work with each other, and I think that we're going to have to see frankly, a more general acceptance of network sharing and asset sharing and spectrum sharing across the board. And I think that in building is no different to that. And then the other sort of the last sort of thing here is there's a bunch of things which are unknown. And I've put AI and blockchain and new devices here, but just to give an example, the AI is going to touch in all of this in multiple places. You're going to have devices that work out their own best way to connect to the network. There may be even gaming the network to work out how to get the best connectivity at the lowest price or the most security or most privacy. You're going to be finding perhaps new business models that are based on shared and decentralized asset ownership using private or public blockchains. You're looking at that potentially also touching with the spectrum sharing models that I talked on before. And so all of this creates a whole set of interesting challenges for systems integrators, for building owners, for carriers, and for software vendors. Not all of these can be essentially catered for explicitly up front, but this puts a premium on flexibility, upgradability, visibility as well, and documentation. And if you like, being forewarned is forearmed. There will be some important changes that crop up, either because of regulatory changes or because of user behavior or IoT. If we know those things are likely to occur, we don't quite know exactly what they're going to look like. We can at the very least sort of build that future scanning and horizon scanning into our business processes, and expect that there also have to be a certain amount of budget dedicated for ongoing maintenance and upgrade of infrastructure in the future. So at that point, I'm going to wrap up. There's an ebook that's going to be coming out shortly, which will touch on some of these topics in more depth. I know I've covered quite a lot of different ground here. a lot of different angles. But hopefully it sort of both frightens people with the spectrum of diversity of possibility, but also makes people more aware of the opportunities and perhaps monetary and revenue opportunities for some as well. So with that, I'm going to hand back over to Amna and to Kelly. I don't know if we have some questions and answers.
Thanks, Dean. So we do have a lot of questions. So let's get started. The first question I have here is that I represent a trade association involved in unlicensed technologies and Wi-Fi's role in developing 5G and the eventual end user rollout. Curious for Dean's main views on bullet point 2, that is the evolving role and type of Wi-Fi networks and small cells, as well as the interplay this will have with sensors, RFIDs, IoT, indoor, on-site, and
right. That's quite a question. That's almost an article in its own right. So, I mean, I've touched on Wi-Fi, small cells I've also referenced. And I think one of the things that's inevitable over the next few years is an increasing shift towards small cells, both indoor and outdoor, particularly with 5G, and especially at the higher frequency bands. And I think that this is going to be often that's run separate to Wi-Fi. In some cases, I know a lot of vendors are talking about locating Wi-Fi and small cell units in the same enclosure, and I think we may see some of that, but often you may well find that they are being run by separate organizations, either owned by or paid for by different organizations. The installation and upgrade and maintenance cycles may be different, and there could be different vendor preferences as well. That said, there will be some instances where you'll see those converge, and certainly a lot of the 5G discussion seems to view Wi-Fi as almost like a sub-element of 5G, and I think from a 3GPP and carrier viewpoint, that might be the case, that you could include Wi-Fi in the infrastructure. But I think that from the building and end user point, there's going to be quite a lot of differences. We see this today, a lot of the Wi-Fi in buildings is linked with the computing infrastructure. It may well share a security framework with the wired LAN. And this means that, for example, a lot of large enterprises struggle with things like Wi-Fi calling on their enterprise Wi-Fi systems, because it's essentially requires a separate set of management tools. It's not impossible, and the better engineered ones manage it, but we shouldn't underestimate the complexity of linking those two worlds together. It's like all forms of convergence. They're only as good as the convergence of the skill sets and alignment of the incentives and requirements of those managing it. And I think whilst there could be some benefits from a theoretical cost point of view of combining the cellular and Wi-Fi infrastructures, we do need to bear in mind that there are separate use cases, separate devices, and often separate people involved in them. So I think that if you like, that Venn diagram is going to get slightly closer, but not completely overlapping.
Thank you. So here's an easy one. Will 5G replace Wi-Fi?
Well, linked to that, no. In a word, I think that there are certain marginal examples where it will make a difference. So, if you're a student who moves between your home address and your studying address, twice or three times a year, you don't want to have a separate fixed broadband account in each location. You might live your life entirely on 4G or 5G if you have good coverage in both places, and if you have flat rate data, and if you're not doing something, watching 30 hours of HD Netflix a week or something like that, which takes you past the fair usage limits, maybe. I think that the sort of the use cases could go either way. In fact, you're seeing some organizations that are becoming more Wi-Fi first with cellular as a fallback, particularly certain of the Wi-Fi centric service providers, perhaps with a background from the cable industry. So I think, as I say, that Venn diagram will have a narrow overlap, But the idea that either we're all going to be running private 5G small cells, or that we're running absolutely everything via a carrier connection and a SIM card, it doesn't hold up. I think there's going to be some interesting corner cases, and we'll no doubt see a whole bunch of surveys, but the evidence for 4G is that actually Wi-Fi use has continued growing even faster than 4G, and there's occasionally a sort of a temporary sort of 2% difference in the gap where you've got flat rate is first introduced, but there's no outright shift from one world to the other.
Thank you. So here's another question. How does Li-Fi fit into the puzzle?
That's interesting. The Wi-Fi, for those not aware, is the idea of using visible light as a networking tool. And there's a whole set of interesting developments that are going on there as to, interestingly, as you shift to LED lighting, away from incandescent lighting or neon tubes, you can start to use the lights as a way of transmitting data. Now, that's great for certain things. But obviously with visible light, you have very strong limitations on line of sight. It's also quite difficult for an end device, whilst you might be able to receive light, sending light in all directions. If you think the typical phone, sometimes you have it in your pocket, sometimes you have it in a bag, sometimes you have a case on it, you have people hold it in different ways. So I think that we're going to be seeing visible light appear for some use cases in some places. It could be for fixed wireless access to a building. It could be used in a building where you have good line of sight within a room. But you do have the sort of inconvenient nature of walls. And I actually think it's not just walls, but if you think about a typical office infrastructure, you may well have cubicles and partitions which move around. So you then end up having to have an AI infrastructure that can deal with moving environment as well to know whether there's, if you like, full three-dimensional coverage. So I think that it's interesting. I think there will be certain use cases where it makes a lot of sense, and I think that on the other hand, I don't think that we're going to be running all our networks on visible light anytime soon.
Thank you. So let's go to one more question. How do you see regulation impact the indoor wireless space in coming years?
That's actually a really, really interesting one, because there's a lot of different touch points with regulatory changes here. Now, I mean, the most obvious one is what spectrum gets released by regulators for what purposes to which carriers, and that's going to be very nationally oriented. I've mentioned CBRS in the US. You have other markets around Europe and Asia where you have other approaches to spectrum sharing that are emerging. So that's the sort of most obvious one. Perhaps the follow-on from that is you're starting to see some regulators looking at whether or not they should be mandating certain levels of indoor coverage as part of the license terms for a certain spectrum. And certainly you've seen that in a couple of bits of Asia, or here where I am in the UK, there was a recommendation or a requirement on one of the operators with one of the 4G bands to provide indoor coverage. And that typically was aimed mostly at residential users, with the idea of making sure that broadband is available on a competitive basis to all citizens. But I think that frankly, we ought to see regulators get a lot more interested in building wireless coverage more generally, especially not just the telecoms ministers of countries, but also the business and economic ministries. If you take a lot of the announcements around 5G and productivity for countries' industries seriously, that implies that wireless is going to need to work indoors. Most manufacturing is indoors. Most hospitals have their operating theatres indoors, and so on. And so I think that we may see some interest, hopefully, from the more enlightened governments, whether it's from the telecom minister or the business or health or industrial ministers, to start to, well, if not put rules on indoor wireless, then at least be cognizant of the requirements and nudge people in that direction.
Thank you. So let's do one last question. Wi-Fi and DAS networks are often at performance odds. Do you see any new direction for DAS networks?
Well, that's an interesting question, and particularly DAS in the era of mid and high band spectrum and MIMO and beamforming is, to my mind, unclear, and it's not obvious to me whether the existing DAS systems fed by single sources are going to be able to cope with the types of either the density of indoor usage requirement, whether we would need to have regulatory or cooperative arrangements between carriers to have shared spectrum in buildings. I think it's going to take a while. Now, how that sits with Wi-Fi is a very good question, because I mean, apart from anything else, the demands on Wi-Fi tend to be more fast moving, and it's going to be, it also depends on on the type of buildings, and so buildings which have lots of visitors are going to be inherently different to buildings which are primarily just used by their own employees, or even just used by machines. In particular, buildings with international visitors, where roaming is often expensive, hotels and airports, the most obvious ones here, are very, very Wi-Fi intensive, and certainly when I've spoken to hotel network managers, that's probably been higher on my list than cellular indoor. Spoke to a hotel IT director, a hotel group IT director in Asia fairly recently, and they were looking at sort of putting one cellular access point almost like between every 2 or 3 rooms, and expecting to sort of replace them almost like a rolling cycle. Whereas for cellular, to some extent, they're constrained by whether the local carriers talk to them even, let alone pay for coverage. And he said that in one national market, he would have the carriers paying for indoor connectivity. In another market, the hotel was expected to pay them. Whereas for Wi-Fi, I think people realise that it's essentially becoming more of an amenity, and it goes along with the heating and the plumbing and security systems and the fire alarm as part of the fabric of the building that people just expect to be there. Whereas I think that rightly or wrongly, cellular is still often viewed as it's nice, not nice to have. People will complain if it's not there, but it's not as obvious who's responsible if it isn't. So I think that you will still see that tension between Wi-Fi and DAS, or Wi-Fi and small cells, and I don't think there's going to be a one-size-fits-all solution to how you fix that.
Okay, thank you, Dean. Let's do one very last question.
Okay.
Does the Google Fi service represent the future of mobile communications, where the endpoint device has the intelligence to decide which network service provider to use?
Depends on the device. It depends on whether it's a general purpose device, whether it's moving, whether it's fixed. Again, depends whether it's brought in by a visitor or an employee. I think that smartphones will increasingly have onboard AI and perhaps multiple radios, and it will be able to sort of arbitrage between different parameters, whether that's price, coverage, speed, security, ownership, service availability. Whereas if I've got an accelerometer on an elevator door, I don't think that's going to be picking and choosing a connection very much. If you like, I was always reminded that the Coke vending machine can't decide to go and stand by the window to get a better signal, and I think that we can probably extend that analogy to think that we're going to have varying levels of autonomy and agency of different devices and different users. So autonomous vehicles, if you go to imagine a car in a parking garage 2 or 3 stories under the building, it may well not have any cellular connectivity at all. It might have Wi-Fi, and so in that case, the autonomous vehicle will have to navigate to the exit to the car park on its own, understanding either with a map or with visual sensors. When it gets outdoors, it could be in an urban canyon. And so it might have some vehicles now have 2 radios or 3 radios. So I think it's going to come down to the sophistication of the device and the cost of the device, whether it's provided by a service provider or owned by an individual or another or a large company.
Okay, thank you. And now we're coming up to the hour, so I would just like to thank everyone for attending, and thank you, Dean, for this amazing webinar. We will be sending out the presentation recording in the next few days, so look out for that, and also look out for our new ebook on Convergence, which should be out in a couple of weeks. Once again, thank you everyone for attending, and now I will disconnect the call.
Thank you very much indeed, Amna and Kelly and everyone else from iBwave. Thanks.
Thank you.